Welcome back. I'm continuing my discussion with Philip Resnik. You can see the previous part of this discussion in the link below. Now we're going to talk about where you can work if you have a degree in natural language processing or computational linguistics. We're talking today about the people and organizations in computational linguistics. Last time we talked about the conferences and journals that make up the community, but that ignored the little problem of a paycheck. People who are part of the community need to get paid by somebody, so who actually signs your paycheck in computational linguistics?
Right. So the way that I usually think about this is in terms of a couple of very broad or general categories or classes of paycheck. One is academia, doing academic research, typically in universities. You also have industry, which has a broad range of different kinds of jobs. You have government labs. And you also have things that are in none of those categories, but are nonetheless places where researchers can wind up. For example, people can wind up in consulting or in policymaking.
Yeah, and we'll talk more about those options in a bit, but let's break down the big groups a little bit more first. Since we're in academia, maybe we should start there.
Yeah, so in academia, one thing that is sort of very standard in the US in particular is a progression on what's called the tenure track, where typically you start as an assistant professor. Then typically one gets tenure and promotion to associate professor, and then finally, eventually many people go on to full professor. So these are sort of the ladders of the academic hierarchy on the tenure track. In addition, you have other academic dimensions like adjunct professors or research faculty.
Yeah, maybe one thing we could talk about is lecturers. And so lecturers typically have a PhD, but they teach quite a bit. And while you can do research, it's not the reason that you got hired. It's a little like being a professor at a liberal arts college. It's great if you enjoy teaching and interacting with students, occasionally doing research with them, but you'd probably get more research done if you had any other job and did research as a hobby. It's clear where lecturers are getting their money, tuition dollars. But where does the money for professors and research professors come from?
Computational linguistics research is interesting compared to some other fields. You can again think about a spectrum. On the one hand, you might have people who do purely theoretical, sit in your armchair or work with pencil and paper research. You don't need a lot of funding for that besides your salary. At the far end, on the other spectrum, you have things like super colliders, right, where you need gobs and gobs and gobs of research money. And computational linguistics is somewhere in the middle, where you need to fund research teams typically because you don't do things solo. And you also need equipment, computing equipment, hardware to run stuff on. Sometimes you need software research licenses. Where does the money come from? Typically, you are applying with research proposals to funders of one kind or another. And one extreme of this, you have things like the Amazon Research Awards, Google Research Awards, Bloomberg Research Awards, where you'll make a proposal and the money comes in as a gift to the university. In some sense, this is the least restrictive. You've convinced people, hey, you should donate to the university so I can do good things. You then also have government agency kinds of research, or sometimes foundations, where you put in proposals. Typically there is a review process of some kind there that is more formalized, and that's coming in and supports basic research as well as applied research. You have government agencies like DARPA and IARPA in the US that have support for basic research, but very often are folded into applications where they have real-world problems they are hoping this research will help solve, and therefore you tend there to introduce the idea of software deliverables and formal evaluations. And then further along the spectrum, you have industry-supported kinds of research, where very often you have an industry source with a very concrete space of problems that they would like to solve, and you are often collaborating with industry researchers working on a specific problem. Again, you could be doing basic contributions, but it tends to be very targeted because paying the piper in this case means having the company be able to look at the bottom line, however they measure that, and be satisfied that what you are doing is actually contributing toward it. So that's a non-exhaustive list that gives you a sense of the spectrum from, in some ways, less restrictive to our fewer strings attached kinds of research to the cases where you are really being paid to produce something that is connected with a product of some kind.
And that's a good connection to the next broad category of jobs. And so you can be an academic being paid by industry to deliver a software product. That can also happen in industry, for example, if you're directly employed by one of those companies. And there are lots of jobs in industry, from creating Google Doodles to delivering Amazon packages to building Minecraft levels for Microsoft. But we're not going to talk about those jobs. We're going to focus on the ones that you would actually use natural language processing for and computational linguistics. What are the sorts of things that you'd end up doing in industry?
Right. Well, before I go into talking in more detail about industry, let me mention that Jason Baldridge and I did a podcast episode with NLP Highlights. That podcast, among other things, discusses things like why one might prefer to choose industry over academia or vice versa. And I think there's probably some discussion there of work-life balance as well, which we should absolutely not be neglecting.
I thoroughly recommend it, and it's a great way of talking about the personal trade-offs that often go into the decision about whether you work for academia or industry. One thing that we should make very clear is that this is on a continuum. So just like the research continuum of unrestricted funding for research versus very applied and directed towards a particular task, the same thing happens in industry as well. There are a couple of very prized jobs in industry that let you do pure research without necessarily contributing to the company's mission. Software engineers are on the other side, and you're working directly on a product. And maybe they'll be able to do some publishable research on a new feature in an application, but most of the time you'll just be dealing with products, perhaps indeed using computational linguistics tools, but they might not be publishable in some of the research venues that we talked about in the previous video.
Right. One of the things that I would emphasize is that in any part of your work life, you always have to pay the piper, right? And I usually visualize this when I talk with my students as a Venn diagram, where on one side you've got what you want to be doing, and on the other side you've got a circle for what people will pay you for. And then the goal in your work life really, and in your graduate career as well, is to make those two circles overlap as much as possible. So as you mentioned, Jordan, there is a spectrum or a continuum. It used to be the case that you had very pure research things. Back in the day, it was like AT&T, Bell Labs. A lot of that disappeared for a while, and now these things have risen up again with things like DeepMind or with research groups within some of the major heavily funded companies. The kinds of things you'd need a whole other video to talk about the kinds of things you do in research in industry. The thing that I would emphasize is that there is always a connection in industry between a need and the research questions that you are asking. There is always, even in the places where it's pure research, an important bridging that has to take place where you are guided by a need of some kind, as opposed to simply asking a research question and being able to pursue it in an unfettered way. And along the continuum, how you demonstrate that you are addressing that need can be different. In the more pure research kinds of environments, it's by producing papers or producing patents, right? Which may or may not connect directly to products. There are things in the middle where there's a tech transfer process, where you are doing research, but you are also thinking in an application-oriented way. I sometimes make a distinction between research on the one hand and what I would call advanced development on the other hand, which can have an R&D flavor to it, but is always guided by a particular problem that you know you have.
The final broad category is government researcher. These are far less common in the United States than in some other countries, but they do exist in the United States. Sometimes you'll have all the freedom of an academic researcher, for example, at the National Institutes of Health, while other times you'll have obligations to, for example, create evaluations, like at the National Institute of Standards and Technology. In some ways, this is a lot like a research professor, except that there's only one source of money, the place you work. Sometimes they make this explicit by having internal funding sources to identify the work that you're going to pursue.
That's true, although you also have to realize that sometimes even government labs have, quote unquote, customers. Right? So you often have something going on at one, say, institute at NIH that is serving some other government agency. For example, looking at medical records in connection with disabilities, which might be something that you are doing in collaboration with or in service to the Social Security Administration.
Another way that you can make a contribution by working for the government is being a program manager for some of the agencies that hand out money to academics. And so you're not doing research yourself, but because you are an expert in the field, you get to decide how a portfolio of millions or even billions of dollars might get spent to change the research landscape going forward.
A category of people who have an enormous impact on research and the research community by helping to define what the problems are, what people should be working on. At the National Science Foundation, you have program officers within various of the programs, and you have people who contribute to the creation of new programs. Similarly, within government agencies like DARPA, you have program managers who are proposing and getting approval for putting sometimes very large amounts of money into a program that then kind of defines the problem that a subset of the research community is going to work on. Let's also not forget people who volunteer their time as editors of journals, right? Being an editor of a journal, or even doing say a guest editor role in a special issue of a journal, is a way of influencing the visibility and often the direction of research that's taking place within the community.
Now that we've outlined the general classes, let's go a little bit into the pros and cons of some of these roles. I spent some time at Google, and it was a big boost to my take-home salary, but what I think is even more alluring for those types of jobs is the great food steps from your desk, a gym as you walk off the street, free classes to improve your German, cooking, or backstroke.
Yeah, those kinds of perks can make a big difference. As I mentioned, work-life balance can be very important. And the things that you experience at work in your work life can be very important to your overall satisfaction of how your life is going. I spent time at Sun Microsystems Labs, for example, and they had a gym in the next building over, and I was in better physical shape possibly than any other point in my life. Yeah, I have a couple of lessons learned from having done startups. I will take a second or two to convey what I think is the single most important lesson that I've learned doing startups, which is that many people in our community start from the tech. They think, wow, I've got this innovative thing and it does things. I can find ways to turn this into a startup and make it be valuable. And with a very small number of exceptions, startup success, which by the way is extraordinarily rare, is
even harder than getting into a top conference.
Oh, way harder. The thing to think about is not the startup that shows people there was a thing they didn't realize they needed. I think Facebook is a great example of that. The vast majority of successful startups start with the need. I have a motto, which is, I'll quote it, quote, find the pain, unquote. You don't want to be starting from the tech. You want to be starting from the understanding of a real world need. And what really makes a successful startup is not purely technology, unless you're aiming for an acqui-hire where you build a startup with a bunch of smart people and you hope to get acquired because they want the people as opposed to whatever it is you're building. In most cases where that's not the model, you want to be thinking from the very beginning about the bridge between the technology and the need it's going to serve, and the idea of a need that people are willing to pay to have satisfied.
Exactly. And once you get enough people to pay for that need, then you can build your own brightly colored office with all the perks that you want. Let's maybe talk a little bit about what happens once you get to an established company on the research side, beyond the perks. Working at a company can be pretty great. While in academia, a researcher kind of needs to be a jack of all trades, in industry, you have a chance, and it's often highly encouraged, to specialize. There are folks who just make tools to better tune the hyperparameters of neural models. You can find your niche and become super specialized.
You wind up with different ranges of specialization. In academia, you tend to have kind of a funnel effect where you start broad and then you get narrower and narrower. And then in some ways you broaden out again, right? So people have described getting a PhD as, kind of learning more and more about less and less until finally you know everything about nothing. That's your dissertation, right? You are the world's expert in that one thing. But then you get out into the world and you need to convince people to pay you to do research, which means you need to broaden out and find out how what you're doing is connecting to things that are more relevant. Similarly, in industry, you can specialize, as you were saying, Jordan. In addition, you can have a role in industry where you are looking for the connections between what you are doing and the broader needs within the company. And that gets into the idea of a tech transfer model, where if you're going into industry, one of the things you want to think about if you want to be doing research is, how does the research then follow a path to getting used in some way? Does it simply get thrown over the wall? Do I have to go try to pitch it within the company to get somebody interested in using what I've built? Do they expect me to move with my research to a development team and be a developer for a while? There are many different models for tech transfer across a whole range of industry.
Right, and this gets to some of the cons of working in industry as well. When you want to work on something in industry, you typically have a boss or a manager who needs to okay the stuff that you're working on. And when you go to submit a paper, it might need to be reviewed by internal researchers, public relations, the legal department, engineers to make sure you haven't leaked trade secrets, and maybe even philosophers to make sure that you're in line with the philosophical motto of the company. In academia, you can just one day decide, I'm going to work on simultaneous translation, and nobody will stop you.
I often describe academia as being the most entrepreneurial form of entrepreneurship. I think of academia as actually, in many respects, being certainly more entrepreneurial than a typical industry job in an established company. But even more entrepreneurial than startups in the following sense. At a startup, you have an idea. Hopefully you've figured out what the need is that's driving this, right? You have to convince somebody that the idea is good and get them to support it, because that's where the paycheck comes from. You build and innovate, and then in the startup world, you reach the point where the focus is no longer on the innovation itself. It's on turning that into a going enterprise. But at that point, right, as academics, we don't do that. We go back to the beginning and say, what's the next question we should be asking? And you have exactly the same set of issues where you need to come up with new ideas, figure out what the right question is, convince people to support it, move it forward, and then go back to the beginning again as an academic.
And another lovely thing about academia is that you're taking this journey with students. In addition to actually doing the work, you're training the next generation of researchers to make their own contributions in the future.
If you think about products that are produced in various jobs, the most important products that we produce as academics are ideas and students. Publications are a measurable, sort of visible product in that sense. But the important thing that we're doing, the real impact that we have, is the ideas and in helping to create a new generation of people to generate ideas of their own.
Taking a little bit of a bigger picture, as artificial intelligence becomes more critical to more parts of society and the economy, it's also important to help advise decision makers on how to effectively deploy these tools. This might be in an official advisor role, but it could also be as a consultant. And these are not typically the types of jobs that you'd get hired for inside of a big company. This is its own animal.
That's absolutely right. And there are various levels. It's hard to become an advisor to a company or an advisory style consultant where they're paying for you to be smart and tell them about their problem, unless you've already gone relatively far in the field and you have a track record. But you do have things that are intermediate. For example, being more of a hands-on keyboard kind of consultant, whether it's working for a consulting company or putting out your shingle and doing that by yourself. You also have sort of affiliated or associated kinds of roles that are not straight academia, straight industry, and so forth. There is an enormous need for people who can simply help wrangle the data. So the whole data scientist role is something that is emerging, and so much of that is text, that being a text data scientist is surely a place where there's a lot of opportunity these days. And again, within the government, you have policy making and policy issues. I know, for example, somebody from Maryland's linguistics department who is, scientifically enormously well trained, but then took that training into the government on the policy side as opposed to doing research herself.
And as we said before, this field is changing very quickly. I can imagine whole new job descriptions of people who, for example, create prompts for GPT-3 generated advertising campaigns or fact checkers for the output of machine translation systems. And not all of those are from my dystopian science fiction side hustle.
Yeah, there's also an increasing area where you have AI sorts of things with humans in the loop. So you have computer-assisted content analysis of various kinds, where somebody on the technical side is engaging with analysts, for example, who are going to take the outcome of the things they produce and then generate reports, make policy suggestions, and so forth. So that bridging role that I've mentioned before between the research or the R&D and the needs can be manifested in specific roles where you actually have people who are doing the technical things and engaging directly with their counterparts, whether those are analysts or other kinds of consumers.
That seems like a really exciting way of how to succeed in a role, in a career in computational linguistics. And let's talk about that a little bit more in our final and next video on the ways that you can contribute to computational linguistics. If you want to see more videos like this, check the video description for the course. That comes from the link down below. You can then see the context and the correct order for watching these videos. YouTube will gleefully show you stuff in the wrong order. If you want other people to see this video, provide a big gradient to the recommendation algorithm by clicking the like and subscribe button down below.